In this video, we will learn how to sketch the locus of points representing the complex number z satisfying the following equation. Let's start off with the basic idea of vectors. I'm drawing a vector. This is the first vector that I've drawn. This is another vector that I've drawn. Let me label the green vector as z1. The second vector, the blue one, I have labeled it as z. Now let me join these two vectors by this purple vector. Let me label this vector as q. Using the rule of addition of vectors, I know that z1 plus q equals to z. In other words, the vector q is z minus z1. If I take the magnitude of q, that is magnitude of z minus z1, which is the length of vector q. Now, let us denote z as a variable complex number. Now, if we write z minus z1 modulus equals to r, it means that we are looking for locus of points z. What is z? The variable complex number, such that the distance of z from z1 is always equal to r. That is what this statement means. Now, our objective is to draw the locus of points represented by this particular equation, z minus something equals to r. Now, over here, we have z1. z1 is a fixed complex number. Let me write z1 as a plus bi. So now I'm writing z minus a plus bi equals to r. Whenever we come across this equation, the locus of points represented by the variable complex number z is a circle. A circle has a center. A circle has a radius. The center of the circle is a comma b. The radius of the circle is r. That means if I draw a small circle over here and this point, the center of the circle is a comma b, the radius of the circle is r, and if I draw a grid over here, this is the real axis, this is the imaginary axis. So now imaginary, real, and that's how the diagram for this complex number will look like. Now, in this particular video, we will be focusing on this. Sketch the locus of points representing the complex number z satisfying the equation. The equation will be of the form z minus a plus bi modulus equals to r. We know that the loci representing this equation will be a circle. The center of the circle will be a comma b, and the radius of the circle will be r units. So let's get started with some example. The very first example is z minus 0 plus 0i modulus equals to 4. This can also be written as z modulus equals to 4. That means if only z is written and there is a magnitude sign, modulus sign, and there are no points written, that means the center of the circle is the origin 0, 0, and the radius of the circle is this value, which is 4 units. Always remember to compare coefficient with z minus a plus bi modulus equals to r. The value of a is 0, the value of b is 0, this value over here is r. Now we can draw a sketch. What I can do is that since I know it's a circle, so I'm drawing a circle first. And let me take this circle and center it at this point. Now I'm drawing the real axis, I'm drawing the imaginary axis, and now we know that the center is 0, 0. We can label this particular point, which will be 4, 0. This particular point would be 0, 4. This particular point would be negative 4, 0. And this particular point is 0, negative 4. Now, how do I get these points? We know that the radius is 4 unit. That means this particular distance, this particular, and this particular distance from the origin till this point in each of the following 4 cases will be 4 units. Now the question is, can we find the Cartesian equation of a circle? Yes, we can. We know that the equation of a circle has a format which is x minus h whole square, y minus k whole square equals to r square. What is h? What is k? This is the center of the circle. And what is r? R is the radius. That means if in this particular question we are being asked for the Cartesian equation, we can say that the center is 0, 0, the radius is 4 unit, therefore the equation will be x minus 0 whole square, y minus 0 whole square equals to 4 square. We can simplify it a bit further. We can say x square plus y square equals to 16. That is the Cartesian equation of a circle. Now let's try some more question. Something like z minus 2 plus 3i modulus equals to 2. Always compare coefficient with z minus a plus bi modulus equals to r. Let's start the process of comparing coefficient. A equals to 2, b equals to 3, r equals to 2. Therefore, the center of the circle is 2, 2 and the radius of the circle is 2 units. This time I'll find the equation first. X minus something whole square, y minus something whole square equals to r square. What are these missing pieces? The missing pieces are this 2 and 3 goes over here. So this is 2 and this is 3. And what goes at the end? That is this particular 2. So 2 square is in place of r square. That's the equation of the circle. Now we can draw the axes and we can plot the circle. So let's draw the imaginary axis. Let's draw the real axis. Let's draw a circle at the corner and then we can bring it in. So this circle, I'm just drawing a size like this. And let us label the real axis, the imaginary axis. Since the center of the circle is 2, 3, so somewhere here is 1 and this is 2 and this is I, 2i, 3i. So this is the center of the circle. Now, we also know that the radius is 2 units. So even though the diagram is not drawn to scale, it has to be realistic. That means the diagram would be touching this coordinate because this is 2 units from the center. It should be passing over here. It should be passing through this point and this particular point. So let's see if this circle fits in. So if I plug it in over here, it's a bit smaller. So let me just take it to the side and let me increase the diameter, the radius a bit, and this is an exact fit. So now that is how we draw a loci on an argon diagram represented by the complex number z minus a plus bi modulus equals to r. In this case, a and b are 2 and 3 and the radius is 2 units. So what have we learned in this particular video? We have learned that how to plot loci of the format z minus a plus bi on the Argand diagram. We also know how to evaluate the Cartesian equation of the circle based upon the above info. All we need to do is to plug in this template: x minus something whole square, y minus something whole square equals to r square. This a actually goes over here and it's officially written as h because that's the standard used in most books. And over here, b goes in place of k. You can even write this thing in the form x minus a whole square, y minus b whole square equals to r square.